Good afternoon, girls. Today let us say about the topic viscosity. See, when two different layers of a liquid are moving with two different velocities, they experience the tangential forces which are called the forces of viscosity. These forces of viscosity, they will tend to accelerate the faster layer, they will tend to accelerate the slower layer and fasten the slower layer. Now these forces are called the forces of viscosity. Now consider two different layers. One layer is moving with the velocity v plus dv and the other layer moves with the velocity v. Now let the distance between the two layers is dz. Now a velocity gradient is set up here, which is nothing but dv by dz. Now what is gradient? Actually, when one factor changes with respect to another factor, we call that as gradient. Here the velocity changes with respect to the distance, so we call this as dv by dz as the velocity gradient. Now the viscous force F is directly proportional to the distance, the velocity gradient dv by dz and A. So here A is nothing but the surface area of each layer. Now this proportionality can be removed by introducing a constant. So F is equal to eta A into dv by dz. Here this eta is nothing but the coefficient of viscosity for any liquid. Now when A becomes 1 and dv by dz becomes 1, F will be equal to eta. Now we can define coefficient of viscosity like this. The coefficient of viscosity is defined as the tangential force required to maintain a unit velocity gradient. Since this is the force per area, we can give the unit for viscosity eta as Newton second per meter power minus 2 or Newton second per meter square. Now let us see what is the dimension for this viscosity. Now we can write F is equal to eta A into dv by dz. Now what is F? F is nothing but mass into acceleration, eta into what is A? Area. So we can write L square and dv by dz is nothing but the velocity by distance again. So the velocity is Lt power minus 2. So what is velocity? Actually it is the rate of change of displacement is velocity. Again it is divided by the distance L. Now what is m? So m. What is acceleration again? Acceleration is again the rate of change of velocity. So we can write this as Lt power minus 2. It is equal to eta into L square. So we can cancel this L. So t power minus 2. So eta is equal to m L t power minus 2 divided by L square t power minus 2. So if it goes to the if this L square and t power minus 2 go to the denominator, m L t power minus 2 L power minus 2 t power plus 2. Now m, so this is actually L power minus 1 and t power minus 1. So the dimension for the viscosity is m L power minus 1 t power minus 1 and the unit for viscosity is Newton second per meter square. Now you consider a liquid is flowing in a wider tube like this. You consider 3 points A, B, C here. Now if we draw a tangent at these points A, B and C, which will give the velocities of the liquid at these points. Now this AB is called as a streamline. So what is actually a streamline motion? Now after some, as time passes, when the velocities V1, V2 and V3, if they are constant both in magnitude and direction, then we call this ABC as a streamline motion or an orderly motion. So what will happen in the orderly motion or the streamline motion is, now each particle will follow exactly its predecessor. So as time passes, all the particles will be traveling with the same velocity. Now so this motion is called as the orderly motion or the streamline motion. Now we can define a particular value called the critical velocity. Now this line ABC is called as the streamline we can call this ABC as a streamline. So the tangent drawn at these ABC points will give the velocity of the liquid at that point. Now we can define a particular value, minimum value called the critical velocity Vc. Now if the liquid is travelling with the velocity below this critical velocity means then the flow of liquid is said to be an orderly motion or a streamline motion. Suppose if the velocity of the liquid exceeds this critical velocity, then the velocity of the liquid will become turbulent. Now what is meant by a turbulent motion? For example, eddies and whirlpools. You would have heard about these eddies and whirlpools. So these are examples for eddies or whirlpools. So these are the examples for turbulent motion. Now we can define critical velocity like this, that is Vc. So the critical velocity is the velocity below which the motion of the liquid is orderly motion and above which the motion of the liquid becomes turbulent. Now this can be demonstrated by a very simple experiment. Now allow water to flow through a wider tube axially. Now allow a jet of ink to flow through the tube. Now we can view the ink will travel in a straight line as long as the velocity of the liquid does not exceed the critical velocity. Now when you disturb the tube, so what happens? The velocity will exceed the critical velocity, so the water will flow with the turbulent velocity. So at that time the ink will spread out. Now this simple experiment is able to distinguish between the turbulent motion and the streamline motion with this simple experiment. This critical velocity depends upon three factors. One is it is proportional to the eta of a liquid and the rho of the liquid and R of the liquid. So what is meant by eta? So the critical velocity depends upon the coefficient of viscosity of the liquid, density of the liquid and the radius of the tube through which the liquid is flowing. Now in order to derive an expression for this critical velocity, let us write the dimensions for all these factors. So Vc is equal to K into eta into rho into R. Now we have removed this proportionality by introducing a constant called the Reynolds number. Now you can write the dimensions for this. Again the velocity is nothing but Lt power minus 1, the dimension K into eta. We have already derived this m L power minus 1 T power minus 1. What is rho? Rho is nothing but mass by volume. So m L power minus 3 and R is again L. So you can group this. So m power A, L power minus A minus 3B plus C, T power minus A. Now equate the coefficients. So here, so B, A plus B, m power A plus B. Here we don't have m here on the left hand side, so A plus B becomes 0. Now equating the coefficients for L, minus A minus 3B plus C is equal to 1 and minus A is equal to minus 1. Now A becomes 1. So you can substitute the first expression A plus B is equal to 0. So 1 plus B is equal to 0 or B becomes minus 1. Again you substitute all the values of A, B here. You find the value of C. So it will also become minus 1. Now you substitute here in this. So Vc equal to K eta rho R. Here R power C. So C value is -1 and rho value is K eta rho B is again -1 and eta value is power A, it is +1. A is +1. So K is equal to Vc by rho R. Now, what is the significance of this Reynolds number? See, just like the critical velocity, the Reynolds number is also able to distinguish whether the liquid flows with the streamline motion or with the turbulent motion. So, if the velocity of the liquid is up to a particular value of the Reynolds number, the flow of liquid is said to be a streamline motion, and if the motion of the liquid exceeds a particular value of the Reynolds number, then the motion of the liquid will become a turbulent motion. So this Reynolds number helps us to distinguish whether the liquid flows with the streamline motion or with the turbulent motion.